So good morning, everyone. As you can see on the screen, today we'll be starting with the subtopic of standing wave. And compared to pressure wave relatively was little more complex topic. Standing wave is not only easier, it is more important also. And before we start standing wave, we'll just recap. We'll just go through one thing what we had done earlier. In this case, what you notice, if you, some of may recall, if two pulses are traveling in the opposite direction. Why I'm taking this example? Because standing waves are also created by waves which are traveling in the opposite direction. You recall, so how do we arrive at what is the shape of wave at different instances of time? We find out using principle of superposition. So we calculated what would happen at t is equal to 3 seconds. And this pulse also will travel a distance equal to velocity into time. It will travel 3 centimeter. This also will travel 3 centimeter. And whenever, so this is the region where this is the all particles which are present within this space. They are affected by two different pulses, and resultant displacement is sum of displacement due to each. And what is important point, what you notice here, just we pay attention to particular point which are at this position. So if here this is the position here, we find the net displacement is 0. So here also, as this wave is progressing, not only at t is equal to 3 seconds, anywhere between 2 and 3 seconds also, any time if you look at this displacement remains 0. So this will be the shape of string at t is equal to 3 seconds. And similarly, if we do at t is equal to 4 seconds also, again we do something similar. We find this particular point always remains at rest. And this is the important thing, and we will observe similar thing happens in case of standing wave also. So when two waves travel in the opposite direction and two waves are of same velocity, same angular frequency and same amplitude. If with same shape, if they travel in the opposite direction, there are certain points in the medium which always remain at rest. And so we have, this is, it gives it rise to different kind of wave. Standing waves are different from traveling wave. In case of traveling wave, all particles oscillate. There's no particle on the string which does not oscillate if it is a traveling wave on the entire string. Whereas in case of standing wave, it is possible that some particles do not oscillate at all. They always remain at rest. Okay, so let's come to what is standing wave and what is the condition under which we obtain a standing wave. The standing wave also is an application of principle of superposition. We have dealt with the case of interference already. Interference, two waves were traveling in the same direction. What is the key difference what we notice here? The standing wave, two waves of equal amplitude and frequency. Frequency also has to be same and equal amplitude. And if they are traveling in the same medium, speed has to be same automatically. But they are traveling in the opposite direction, similar to the wave pulse what we have seen in the previous screen. So whenever such thing happens, it gives rise to a different kind of wave pattern, which is called standing wave. Let's understand. And how do we arrive at that wave pattern? We arrive by simple principle of superposition. Let's take two waves which are traveling in the opposite direction. So this is the first wave, and we notice this wave also has omega. This also has omega. And since velocity is the same, wavelength also will be same if omega is same. This also is k, this also is a k. Only thing what we notice, in one case it is negative sign, other case it is a positive sign. So it indicates and amplitudes are equal. So two waves of equal amplitude, equal frequency, traveling in the opposite direction, and same speed, hence lambda also same. And there's some phase difference, we don't know. So this is something, just since we are not sure, since we are taking general case, we are taken, there's a phase difference lambda, delta also. So if I take, if so this is something in a medium, and if this in a string or in a wire, these waves are traveling. So if we want to find out what will be the motion of a general point x at time t. So what is resultant motion of particle x at time t? Both are variables. So x and t, which is general point, and resultant variation will be, resultant displacement will be sum of the displacement due to each wave. The resultant y will be sum of these two quantities. This is nothing but principle of superposition. Now what we notice here is amplitudes are same. So if I take a common, this particular thing is similar to sine c plus sine d. This is similar to sine c plus sine d. So I can apply, I can combine these two into one. These are two things, the linear combination of two sine function. Using sin c plus sin d, we can combine. So sin c plus sin d equals 2 sin c plus d by 2. So when you add, so this is the expression we get here. Very simple application of sin c plus sin d formula. So we get resultant wave is equal to 2a sin kx plus lambda delta by 2 and cos omega t delta by 2. So one immediately the difference what we notice here, this function which is of the form a ax plus minus bt, in this case it got separated. It is not of the same form. So moment you get this waveform is not a traveling wave. It does not meet this condition. It's a different kind of oscillation. That's what we need to understand. What does it lead to? Let's take up what happens if it is traveling in a case of string. And you understand here, string is something in our normal life also. We come across oscillation on a string very often. What is an example of oscillation of a string and about sound it creates? All string instruments, all string musical instruments are fall into this category. What we notice here in the string also, if we take a guitar string or any other musical instrument, you have a wire, a string, which is fixed at two ends. And you notice which is fixed at two ends. And what you notice here, and some of you may notice, and when you strike a particular wire of a guitar, it emits a sound of a particular frequency. And there are multiple strings. The different strings, they emit sound of different frequency. It doesn't matter where you strike. So the frequency, what we hear from the wire, does not depends on how you strike the wire. The frequency depends on the property of the wire. What is the property of the wire? What are things which are property of the wire? What are the factors which affect the frequency of sound emitted by a wire of a guitar? Can someone tell me? What is your guess if from your understanding? What factors may affect the frequency? You know, different strings are there and different strings emit different frequency. And doesn't matter whether you strike, somebody strikes the wire, we have the similar sound, similar nature of sound coming from the wire. If you strike it harder, amplitude may be more, decibel level may be higher, but frequency remains same. And some of you those who have used musical instrument, I think several of you might have done so. See, when we tune the wire, we have some kind of knob and we turn the knob to tighten the string or loosen the string. When we tighten the string, what exactly is happening in the string? What is the effect of tightening of the string? What does it do when we tighten the string?
Tension.
So when we tighten the string, what will happen? Tension will increase. But what is the effect of increase in tension? If the tension increases, can you think of what happens to wave motion on a string if tension increases? Wave velocity is a function of tension. The wave velocity changes. And there's a term nu also. Why do we have multiple wires in case of a guitar or any musical instrument? Different strings, you'll notice their cross sections are different. Mu value is different. So T is a part of characteristics of wire. Mu also is a characteristics of wire. Hence, speed of wave also depends. Each string will have a different speed of wave. But it creates a sound of a particular frequency. And that's what we are trying to understand. Why does it emit sound of a particular frequency? How we can predict, how we can calculate, and how we can control. So this is the case, any musical instrument fall into the category. And there also, how do we get, and can someone think of, how do we get two waves traveling in the opposite direction? The two waves opposite direction because of reflection. So if any wave is created here, if wave travels on reflection, it creates a wave traveling in the reverse direction. And if there's no loss of energy, same amplitude. So since ends are fixed, the reflections are happening at the end, it creates waves traveling in the both direction, which is standing wave. So whenever we strike any musical instrument, what kind of wave is getting created in the string? It is creating a standing wave because of reflections happening at both ends. And that's what we are trying to understand. What is that kind of wave and what we understand here? So we take, this is a general case of a standing wave. Two waves of equal amplitude and frequency traveling in the opposite direction. Mathematically, we can add it up, very easily arrive at this expression. Then we apply this condition to a string fixed at two ends, and length of the string is L. So one end is x is equal to 0, other length becomes L. So moment it is fixed, what we call it, these are the boundaries. We need to apply boundary condition to this equation. Can anyone think of how do we apply boundary condition to this equation here? What has to happen if two ends are fixed? If this end is fixed, so at x is equal to 0, what has to be the value of y at x is equal to 0 at any instance of time? If x is equal to 0 is fixed, that becomes my boundary condition. If x is equal to 0, this point must remain at rest at all times because it is fixed. That's a boundary condition. So in this terms of equation, what I write, y is a function of x as well as time. If I choose x is equal to 0, and for any value of time, this whole expression should come to equal to 0. So any value of time, so this term is not 0. If this whole expression comes to 0 at x is equal to 0, this term must equate to 0 at x is equal to 0. And this term will equate to 0. Actually, if x is equal to 0, it becomes equal to sine delta by 2. It implies the delta term must be equal to 0. Waves will get created. What you call reflected wave will get created in a such a way this term delta will not be non-zero value. It will be 0. That's the first boundary condition. I hope this is understood. Shreya, have you followed this point?
Sir, can you repeat it once?
Can I repeat? Okay, tell me, have you understood how did we arrive at this equation? Have you understood this point?
Yes, sir.
And this is simple two equation. We have applied sin C plus sin D. Then we said string is fixed at two ends. What do you understand by fixed at two ends, Shreya? In normal words, how do you explain if x is equal to 0 and x is equal to L is fixed? What does y indicate here? Shreya, what does y indicate?
The motion of particle.
It's a displacement. There's motion of particle displacement in that transverse direction. So if end is fixed, do you think you take a string? Just imagine a guitar wire. It is fixed at two ends. Will this point which is fixed at x is equal to 0, what is the value of y at different points of time? Will y not be 0 at all instances of time? That's what you're writing. If it is fixed means its motion is 0, it will always remain at rest. Y will be 0 at all values of time. So is this for different value of time, this term cannot be 0. So it means if it has to, this term has to be 0, which is this term has to be 0. And for this term to be 0, at x is equal to 0, if I put x is equal to 0, sine delta by 2 has to be equal to 0. If sine delta by 2 is 0, is possible only when delta is equal to 0. Delta becomes 0. Second boundary condition we apply, similar thing has to happen at other end of the string also. So in this case, what we are substituting? Okay, this term also has to be 0. Delta is already 0. So this expression also has to be 0 all values of time. So what we have substituted? Delta is 0 in place of x, we have substituted L here. So this equation also has, this is the second condition. Let's examine the second boundary condition. This is a condition. Resultant wave now, delta is gone from first boundary condition. This equation. So if it has to 0 at all instances of time, this term is non-zero. It means this term has to be 0. What would make this term 0? If the sine of any particular angle is 0, it means that angle has to be equal to n times pi. And n can have value 0. We are not taking 0 here, the length is non-zero here. So we take this term here, KL has to be equal to n pi. We are using simple property of a sine function. This term has to be equal to integral multiple of pi. 0 cannot be there because L is not 0. So it has to be either pi, 2 pi, 3 pi, or in general terms we can write, and K has to be written as pi as 2 pi by lambda into L has to be equal to n pi. And n can have value 1, 2, 3 and all these terms. Okay, so this is basically when only this kind of waves are possible. Other waves are not possible. That's the condition we are arriving at. Only certain types of waves will get created in a string of which is fixed at both ends of length L. First condition, this is second condition. So if we rearrange the term here, what we find, the length of the string is related to wavelength and value of n here. N can take different value 1, 2, 3, 4. So how do we, in terms of words, how do we express this relationship? Length of the string will be integral multiple of half the wavelength. Length of the string will be equal to, it can be half the wavelength, it can be twice the half wavelength, which is equal to lambda. It could be 3 lambda by 2, it can be 4 lambda by 2, it it can be 5 lambda by 2. But it cannot have a value, a wavelength in anything other than those numbers. Length of the string must be integral multiple of half wavelengths. Only those waves will sustain, other waves will die out. The other waves will not sustain in the string because they do not meet the end condition. And this term we have written in terms of wavelength. It can also be written in terms of frequency. So frequency, because we understand music better in terms of frequency, we can also write this expression. We simply use lambda is equal to speed by frequency. So we replace with this term lambda by speed, v by f. So what we get here, the frequencies which are possible are these, n into v by 2l. And we can also write as what is v is tension by this equation. And this is a very important equation we use very often. And standing wave, as I mentioned here, the standing wave is a relatively easy topic and important topic. Maximum number of questions in this chapter come from topic of standing waves. Very rarely we come across questions which are on pressure waves. This equation based on two conditions. So this is something in 2 ways. What are two conditions we have come up with? One is same, this equation. The same equation can be written in different form. These two are not different. Only thing lambda has been replaced by v by l. So one is in terms of relationship between wavelength and L, and other tells you what is the frequency of vibration which are possible. Only these frequency of vibrations are possible, other vibrations are not possible. So when you have a guitar string with a particular tension, particular value of mu, you get sound only of a particular frequency, not other frequencies. And when you change T value here, when you tighten or loosen the string, frequency will change. T term is changing. And we have different strings. Even in all musical instruments, we have multiple strings. If the string value, some string is thicker, mu value is more, the frequency also will differ. So this is the equation which affects the frequency of oscillation created in a string fixed at both ends, which is the case in all musical instruments which are based on string motion. All string instruments work on the similar principle. It emits sound of a particular frequency, and those particular frequency comes because of it is fixed at two ends using boundary condition, and we are used to standing wave condition, waves traveling in the opposite direction. Why the wave travels in the opposite direction? Because onward wave gets reflected from the fixed end. So you have wave and its reflection, and this so many waves keep getting created, keep traveling. Let's explore this further. So what we have come, so basically we have come up with these two formula. Based on previous derivation is kind of the previous thing is understanding. Mostly it is understanding application of this part. So now we'll understand what is significance of n term here. See, for any given string, the length is fixed, the tension and mu is fixed, hence the velocity is fixed. Okay. Only thing we can change, other terms can L can change, V is fixed. Yes, what is the question?
So we took delta is 0, right, sir? In the
Yes.
like that's the reflected wave, right? But there is supposed to be some sort of a phase difference, right?
See, when we write this equation, one thing you need to understand here, any wave, when we write in sine and cos, we can take x term as different points also. See, when we take phase difference here, see, when we write this equation, okay, I'll come to that point later. Whether we see that later, how does it happen? Okay, so, but this is something, is there any denying the fact? See, we have assumed, can we, that case and this case is slightly different. When we create oscillation in a string, and we create only two waves traveling in the opposite direction, is there any different in case of oscillation in a string? And only two waves traveling in the opposite direction? See, there are two cases. One case you can have long wire and it is fixed at one end, it gets reflected. What happens in case of a string instrument? In a string instrument, actually it is not two waves. There are how many waves are happening actually to where, how many waves are getting formed here? You see, multiple waves are getting formed. Okay, so to some extent, yes, we can say reflection is happening. Some principle of reflection are there, but it's a little different in the sense that this. Okay, how else we can explain why minus sign is missing? Okay. I'll come to that point again later. Okay, so let's see that one. I'll just explain why this minus point is missing. And that has to do more with the choice of coordinate system also. We'll come to that point. So let's say this is the equation. And but since we were not sure what that phase change will be, we have taken as a delta. And only where this end conditions, mathematically, end condition can only be met when the delta is equal to 0. Okay. What is fundamental frequency? Now we define certain terms, and these are more like definitions. When we have this number here, only thing in vary is whatever oscillation is possible, all such frequencies or all such wavelengths which satisfy this equation are possible to form standing wave. Other wavelengths and other frequency will not exist. So which are the frequency? Is there only one frequency possible? No, there are multiple frequency possible for different value of n. So fundamental frequency is a minimum possible frequency at which a string can oscillate, and minimum possible frequency will correspond to n is equal to 1. When you substitute n is equal to 1, that's called fundamental mode of vibration. In case of fundamental vibration, it's a minimum possible frequency, and minimum frequency n is equal to 1 is equal to v by 12, and we denote as f naught. F naught is v by 12, which is corresponding to n is equal to 1. And in that case, length of the string will be equal to half the wavelength. Length of the string will be equal to half the wavelength. So if we visualize how it will happen, let's understand here. So suppose this is a string fixed at both ends, and which is the case in all musical instrument. And if it is vibrating in fundamental mode, see, what does this indicate here? This indicates half the wavelength. So the length of the wire has to be equal to half the wavelength. So half the wavelength will form in the length of the wire. This is how the string will oscillate. We'll discuss a little more. And what we find here, these 2 points are called nodes, because these points will always remain at rest. Okay, let's look further. And this equation. So when we substitute what is special about this equation? Once we find the value of lambda as equal to 2L, I can find a particular value. K also is fixed. What is K? K is equal to 2 pi by lambda. Let's put the value of lambda is equal to 2L. It becomes 2 pi by 2L, or K value becomes equal to pi by L. So we substitute this equation of a standing wave when it is oscillating in fundamental mode, or n is equal to 1. This is oscillation. With this oscillation, let's try and understand what does equation indicate. This equation also, let's see, if we compare this equation, our typical SHM motion, this equation, what does it give you? It gives you motion of all particles on the string. If I substitute any particular value of x, it will give motion of that particle. How does its motion vary with time? Okay, so if I compare with this SHM equation, what do we find here? Typically, SHM equation indicates what? Typical SHM equation is y is equal to some amplitude into sine or cos term. It could be sine term, it could be cos term. Even this also could have been written in a sine also, it doesn't matter. You can also write as sine of omega t plus pi by 2. So what we find here also, it looks similar, because there's an amplitude here, and there's an oscillating term which varies the sine function. This also has an oscillating term. Oscillating term, it is varying with time. It is not constant. And this omega, where does it come from? This omega comes from the basic wave. We say when two waves are forming a standing wave, we call those as constituent waves. Constituent waves form a standing wave. This omega comes from sine. What is 2a? 2a is the amplitude of each wave. The standing wave, this term is 2a. This thing, while you can compare with SHM, what we understand from this equation, all particles here, they undergo SHM with same angular frequency omega. But depending on value of x, amplitude is varying. This equation indicates oscillation of all particles on the string with same omega. Only thing, as I substitute value of x, I find different value of amplitude. Okay. So all particles are in the same phase. All particles, if you write equation for x1, x2, x3, this term, only thing what will happen, amplitude will keep on changing. So if I have to draw the shape of string, so whenever I substitute any value of t, it gives you shape of a string at t is equal to 0. So in this equation, if I substitute t is equal to 0, it will give me position of particles at different positions of a string. It will give you value of y for different value of x. In other terms, it will give me the shape of a string at t is equal to 0. What is the shape of the string at t is equal to 0? Moment I substitute t is equal to 0, this term takes the maximum possible value. This term takes a maximum possible value. This term becomes equal to 1. And so every particle, so if I write this equation, see, this thing I could have written as ax into sine of omega t. What does ax indicate here? Amplitude of particle at position x. The moment I substitute here t is equal to 0, what is the y of every particle? Every particle would be at its positive extreme. So at t is equal to 0, this will be the shape of the string. All particles at its positive extreme. And this gives you amplitude. So what happens? This particle has this is amplitude of this has amplitude this much. This particle has this amplitude. This particle has this amplitude. So different particles have all are oscillating, but different particles are oscillating with different amplitudes. And of course, the node will have 0 amplitude. So at t is equal to 0, all particles at the positive extreme. And which particle will have maximum amplitude? The maximum amplitude will be for ax has to be maximum, or this term has to be maximum. When does this term become maximum? What is the maximum possible value of this term? For different, it is varying with x. So this will become maximum when the sine function becomes equal to 1 or minus 1. So when sine function becomes 1, the maximum amplitude is 2a. The maximum amplitude anywhere on the string, if this is the point where you're having maximum amplitude, this will be 2 into a being the amplitude of each wave. And where would this occur? This will occur at a point where this term has to be equal to pi by 2. Then only it will become maximum. This term has to become 1. So pi into x by L is equal to pi by 2, or x is equal to L by 2, which makes common sense. So if this is a node and this is a node, all particles oscillate with varying amplitude. And the maximum amplitude occurs at the midpoint. And this point where maximum amplitude takes place is called an antinode. We use sign A to denote antinode, or you can call it AN also. So this is the shape of wave at t is equal to 0. And since all particles at the positive extreme, you say all particles are in the same phase. So can we also draw shape of the string at t by 6? What will happen at t by 6? See, when we substitute t in this equation, which term will change? So if I write what is y, y can be written as position is equal to ax cos of omega t. Ax into cos of omega t. What does ax indicate? I hope you understand. Ax indicate if I substitute different value of x, I can, this term is not varying with time. So this remains constant. This is a node t function. So this amplitude ax indicates amplitude at distance x. What happens if I substitute t is equal to t by 6? If I substitute t by 6, this term omega is equal to 2 pi by t into t by 6. It becomes equal to pi by 3. What is pi by 3 equal to? What is cos pi by 3 equal to? 1 by 2. So this term will become 1 by 2. So every particle will have a displacement which is half of its amplitude. So at t is equal to t by 6, if I draw a shape, this was the amplitude position, all points in the string will be like this. It will be at half this position. That's how the shape of the string will be at t by 6. Let's substitute what will happen at t by 4. In t by 4, I will substitute t by 4. So at t is equal to t by 4, if I substitute here, what are you going to get here? So this will be equal to cos of 2 pi by capital T into time is t by 4, which is equal to pi by 2 is equal to 0. This term will become 0. It means every particle will be at its mean position. So at t by 4, the shape of a string will be like this. And likewise, it will continue at t by 2. T by 2, it will go to other extreme. So this is how the string will vibrate in fundamental mode. This is how the string is vibrating. So what we understand here, this is standing wave getting created. This equation is standing wave. All particles oscillate with same frequency, frequency being same as the frequency of the constant wave, but different depending on their position. Different particles will have different amplitude. And the point having zero amplitude, which is always at rest, is called node, and point having maximum amplitude is called antinode. And in between, and distance between node and node is equal to, here what is the distance? L is equal to lambda by 2, and since this is lambda by 2, the distance between node and antinode will become equal to lambda by 2. The distance between node and antinode is equal to lambda by 2. Okay, so that's the standing wave which gets formed. Okay, so nodes are the points which always remain at rest. Distance between two nodes and antinode, distance between node and antinode is equal to lambda by 4. Not only in fundamental mode, we'll see later on also. So between node and node, antinode, and node, successive node and antinode and nodes will occur. Of course, whenever there's a two nodes, in between an antinode will occur. This is a sine function. Fundamental mode, only half wavelength forms in the string with two nodes and one antinode. This is fundamental mode of operation. What we have done, we have understood only for n is equal to 1. How the string will vibrate or how the standing wave will get formed on a string fixed at both ends corresponding to n is equal to 1. Similar, n is equal to 2 is possible, n is equal to 3 is possible, n is 4 is equal to possible. So we'll understand this is how the string will appear to look like in vibration. Shreya, is this understood? Or should I repeat again?
Understood.
Okay. Now you see what are other modes of vibration. When we talk about other modes we are talking different values of n. What are the fundamental mode? Least possible frequency corresponding to n is equal to 1. Then we pay each value, we will have another value. What is the next higher normal mode? Next higher normal mode is called first overtone. That's a word, musical word what we use. What is first overtone? Is a frequency, next frequency higher than fundamental frequency. Fundamental frequency is the minimum frequency of oscillation of a fixed string. So for n is equal to 2, when we substitute n is equal to 2 here, the string there will be two half wavelengths. And if you substitute n is equal to 2, this term is equal to f naught. So first overtone will be equal to first overtone frequency will be twice the fundamental frequency. What we understand in case of next higher normal mode of vibration, wavelength becomes half. Wavelength becomes half. Earlier wavelength was equal to lambda by 2. Now the wavelength becomes equal to, wavelength becomes half, and L is equal to now lambda. Earlier the L is equal to lambda by 2. Earlier length was 2 lambda, 2L. Now the wavelength becomes equal to L. So wavelength is half, frequency is twice, which has to happen. Well, velocity remains constant. Velocity is not changing in different modes of vibration. Because velocity depends on tension and mu only. And so here wavelength becomes half, frequency becomes twice the fundamental mode. And this is how the string will oscillate. Why they have two loops here? As we already mentioned, this is lambda by 2. So how many half wavelengths? Two half wavelengths. So this is how the string will look like. And when two half wavelengths, the midpoint here has to again forms a node, and in between node and antinode. So this is again this length is lambda by 2. This length also is lambda by 2. Or we can say two loops are forming, and each loop is between two successive nodes. So this is called harmonic. So when we use n is equal to 1 is called fundamental, and our first harmonic. N is equal to 2 is called second harmonic. N is equal to 3 is called third harmonic. Harmonics are multiples of, harmonics are called integral multiple of fundamental frequencies. And the second harmonic is also first overtone, and third harmonic will be second overtone, fifth harmonic will be fourth overtone, and likewise. Overtone are measured starting from fundamental one. The next higher one after the fundamental mode is called overtone. And that's a medical, more like a musical definite terms we use. In second harmonic, two loops are formed, two half wavelengths are formed. And when two half wavelengths are formed, there are three nodes and two antinodes. And third harmonic, in case of third harmonic, n becomes 3. And frequency of third harmonic, what does third harmonic mean? N is equal to 3. Frequency of third harmonic is, we substitute 3 here, is 3 times fundamental frequency. And third harmonic is equal to second overtone. And how would it look like? This is how the shape of the string will look like. It will form 3 loops. each of lambda by 2. So this will be 3 lambda by 2 is equal to L. That's the equation it will form here. And 4 notes and 2. So in fixed string, all harmonics exist. So whatever fundamental frequency we have, it can also oscillate in all frequencies which are integral multiple of fundamental frequencies. All frequencies which are integral fundamental frequencies are possible in case of fixed string. So what I understand here, we have and basic equation itself is different. We have already noticed some differences between traveling wave and standing wave. Just to have a better clarity of differences between traveling wave versus standing wave. In case of traveling wave, what happens? The energy travels. The energy travels from source to points away from the source. Energy moves away from the source where disturbance is created. In case of standing wave, we can prove that point. We're not going to the proof of that, but standing wave, energy within the loop. Let's take a previous case also. See, if I take energy, this point always remains at rest. It means no transfer of energy taking from one side to other. So whatever energy is there within one loop, it remains confined within the loop. The energy does not get transferred from one loop to the other. So no transfer of energy. In traveling wave, the energy travels, standing wave, energy remains constant. And traveling wave, all particles have the same amplitude, though phase may vary. In standing wave, amplitudes vary. That's why we form nodes and antinodes. In traveling wave, phase changes continuously with distance. And that's the basic property of traveling wave. And here, phase of all points within two nodes is same. See, if I plot this, how would when it is vibrating in, what is this mode? How do you call this mode as? How many half wavelengths are forming here? 2 half wavelengths are forming. So this vibration is n is equal to 2. Or we can call it second harmonic or first overtone. And when it is vibrating like this, when it is extreme end, the string will look like this. When it is looking like this, phase of this is pi by 2, and this phase is minus pi by 2. So what we find, all particles of the string, which are part of half wavelength, they are in the same phase, but these particles are within phase with each other. But two adjacent loops, they are out of phase. When this reaches positive extreme, this part of the string reaches negative extreme. The wave shape will not be like this. The string will oscillate like this. And what will happen? This is, if this is the case at t is equal to 0, at t by 4, we have seen earlier also, all string will come to the mean position. So in case of standing wave, there are instances when the whole string becomes straight. When it becomes straight, means there is no potential energy, entire energy is in form of kinetic energy. So all points, in case of traveling wave, all points cross the mean position at different times. Here, all points cross the mean position at the same time. So why I say what to cross here? They are not at rest. They are at the mean position. But at this instance, see, if this is at t by 4, all these particles are in their downward motion at t by 4, and all these particles are upward motion. So they are all in motion. So all particles are in motion, and they cross, all particles cross the mean position at the same time. This half is crossing mean position from upper direction, hence velocity is downwards, and this set of particles, or this half length of the string, is moving from lower extreme to upper direction. So here velocities are in the opposite direction, and they're out of phase. The phase difference is pi. And the majority of questions what we have in a string wave can be easily be solved using a couple of equations, and they're not very difficult, simple. I think this is one of the easier topic to deal with. Though the derivation, some of this you may, how do we arrive at, some of you may have little difficulty in understanding, but solving numerical is fairly straightforward and simple. Now let's try and understand standing wave equation better with the help of a numerical example. So what is given here? Moment I see this equation, so even it is not mentioned here, I should recognize the fact that this is not a traveling wave equation. The traveling wave equation, basically x term and t term come in the same cos or sine function. Here they are separated. Okay, so this is standing wave equation. In a string of length is given 60 centimeter fixed at both ends. This is the equation represented here. So in this case, okay, so where x and y are in centimeter, x and y are both are given in centimeter, t is in seconds. Okay, so this equation, if you want to compare this equation, what we have done, this is has specific values, whereas our general equation was something like this. Our general equation was 2a sine kx cos of omega t. If I compare here, we can find different things. What are things I can find here? I can, from this equation, I can find out the value of omega here. This term is omega. We can find the value of k, hence we can find out wavelength also. And we can find out the wave speed also. So moment this equation is given, omega is known, value of k is known. In this string, what is the speed at which wave will travel is omega by k. See, this standing wave has been formed because of two waves which are continuously traveling. See, the string, the waves are traveling. The two waves are traveling in the opposite direction, and what speed wave are traveling? Omega by k. So this is all these things so we can find out. Now let's look at what are the questions which need to answer. What is the maximum displacement at x is equal to 5 centimeter? And if we have to answer this question, in my opinion, if someone has to answer this question, if this equation is given, it even does not require any knowledge of a standing wave. It just requires understanding of basic mathematics. And let's see whether we can understand also, but even this is such a simple question. When would the displacement be maximum at x is equal to 5? When would displacement be maximum at x is equal to 5? Anish, can you tell me what is the condition for maximum displacement at x is equal to 5? How do I find out maximum displacement at x is equal to 5? Anish?
Yes, sir.
Can you think of how to find maximum displacement? And I'm giving a hint. Finding answer, it requires no understanding of standing wave. It just requires understanding of mathematical expression and how to find this maximum value. See, whenever I talk of maximum, it means its value is changing. Then only come across the term maximum. Is the displacement, is the value of y or displacement of particle at x is equal to 5 changing? Is the displacement constant at x is equal to 5 or is it changing, Anish?
It's constant. No, sir. No, sir. It's
There's a
changing.
t term here.
Yes,
This term is changing. I've understood. Now
yes,
slowly you're realizing what is happening. Different values of t, this term is changing. And that's why I said, if you want to use little bit of your understanding of frequency speed or standing wave is same as that of constant wave. Now we are talking about displacement is maximum when this term is varying. The displacement y will be maximum when this term is maximum, because this term is constant. Moment I put x is equal to 5, this term becomes a constant. So y will become maximum when this term becomes maximum. Y is maximum when cos omega t is equal to 1. And since we are talking about magnitude of displacement, it will become maximum whether cos omega t is +1 or -1. If it is +1, it will be positive extreme displacement. If -1, negative extreme displacement. Was it difficult, Anish?
No, sir.
So understand, this one did not require any other understanding, just simple understanding of mathematical expression. We got to find an answer. So this term is equal to 1. Now it becomes easy. What is the maximum value of y? So maximum value of y maximum at x is equal to 5 centimeter will be equal to 4 sine of pi into 5 by 15 into 1 into plus minus 1. That's the value it has to have. And how much that will come to? That comes equal to pi by 3. 4 sine pi by 3, which is equal to 2 root 3. So this we can find. Now next question. Now comes a little bit of understanding of standing wave. What are the nodes located along the string? How do you find nodes located along the string? What are nodes here? Shreya, what do you understand by nodes? Alad?
Sir, like, should we take it as greatest integer function only if they ask it?
Pardon me, if we
Should we take it as step function only if they mention it, sir?
yeah, I'm not clear what your question is. Where's the step function?
Y equals 4 times square bracket.
Okay,
of
okay,
y.
okay. Okay, oh, okay. No, so you are assuming this is a step function or something. It is greatest integer function. It is not. It's just like a bracket. It's just a bracket. Okay. So don't overthink. This is just a bracket. Okay. So this is it is not. See, it is not mentioning that this bracket indicates GIF. No, it does not. It is not mentioned here. Take as a normal bracket. Now, Ahlad, can you tell me what are nodes mean? What is your understanding of nodes, Ahlad?
Where at all, at any time, the displacement from mean position will be 0.
No, so basically, what is nodes? So which are always at rest. A very simple way I have to say, which are always at rest. And how do you find those points? There are two ways of finding nodes here. Can you think of one way of finding the node? How do you find the nodes? Why is always rest? It means at those points, y is equal to 0 for all values of t. That's what it means. That's nodes. So what is the for which value of x? This is 0 for all values of t. So what has to happen if it has to remain 0 for all values of t? The sine function has to be 0. So for it to remain, sine of pi x by 15 has to be 0. So all those values of x which satisfy this equation gives you position of node. Anish, is this understood?
Yes, sir.
Easily can you find position of node? So
Yes,
what has to be the value of nodes here? So this is something sine is 0. For what value sine is 0? Sine is 0 for n pi. So it could be value, it could be 0, pi, 2 pi, 3 pi. And we can find. So let's put this, that's one way of solving. So what we substitute here, one is x is equal to 0, corresponding to n is equal to 0, x is equal to 0. So of course, the end of the string, x is equal to 0 is a node. When we substitute x is equal to pi, so when we substitute x is equal to pi, when we substitute this value, take n is equal to 1. So when is pi x by 15 is equal to pi, it gives you x is equal to 15. Second is at 15 centimeter. Do I have to find now if this, and what is this distance indicate 15 centimeter? Does this 15 centimeter has a special meaning here? What does 15 centimeter indicate here? Distance between two successive nodes. This is first node, this is second node. What is the distance between two successive nodes? Is there any special length? What is this, the length called? This is nothing but lambda by 2. This is nothing but lambda by 2. So again, the next node also, if from 0 to 15, next will open to 30, then will open 50, then will open 60, and then 75. But length of this string is only up to 60. So where would the nodes occur? Nodes will occur 0 centimeter, 15 centimeter, 30 centimeter, 45 centimeter, and 60 centimeter. So can you say which harmonic it is vibrating in? Bhagishri, is this understood?
Yes, sir.
Can you tell me which harmonic? You understood the term harmonic?
Yes.
No, so if I show a string which is vibrating like this, so can you tell me which harmonic this string is vibrating, fixed at both ends? Which harmonic is it?
Sixth harmonic.
I'll hit on your head. You are not able to count also. Sixth harmonic or fifth harmonic? How many are there? How many lambda by 2? L has to be equal to n lambda by 2. How many lambda by 2 you count? 1, 2, 3, 4, 5. This is n is equal to fifth harmonic, and this one is called fourth overtone. So in this case, how many harmonics? One way I can find out here, see from this equation also, what is the second way of solving this question was? Second way of solving this question was, I know the value of k here. What is k equal to? I find the value of lambda, and nodes will occur at every lambda by 2. Second way I can, second method of finding nodes was find lambda, then nodes form at lambda by 2 interval. So first one, of course, 0. And how do you find lambda? From k value. K is equal to 2 pi by lambda is equal to k. which is equal to pi by 15, which gives me lambda is equal to 30 centimeter, or lambda by 2 is equal to 15 centimeter. So nodes will form at a successive interval of 15 centimeter. Dhanshri,
Yes, sir.
is clear?
Sir, can you hear me? Yes, sir.
Yes, I think your voice is slightly getting distorted. But have you understood? Yes or no, I can understand.
Yes, sir.
Okay. I think this voice is still not. Okay. So this also, what is the velocity of particle at x is equal to 7.5 and t is equal to this? How do we find velocity of particle? Again, to find velocity of particle, I don't need understanding of standing wave. Jaideep, can you tell me how do you find velocity of particle at this particular position at this particular time?
Just substituting in the formula.
That will give you y. But I have to find velocity.
Once differentiating it and then
Differentiate.
substituting.
So basically, we differentiate, we find dy by dt. And after finding differentiating with time, substitute x and t. We find the particle velocity at t is equal to 0.25. And can we write the equation of component waves or constituent waves? If this term is 2a, so each wave has to have amplitude equal to a. So if wave and k value remains same as this k, so k, in terms of kx, I could have written as 5 pi x by 15 minus omega t. This omega would remain same, 96 pi t. That will be one wave. And what will be the second wave in that case? These are the two constant waves. So constant, when we write constant wave, this term, this gives k value, this gives omega value, and amplitude of each wave is half of the resultant amplitude. Next question. And this is something you can relate to. This is how the actual musical instruments are. If they have some linear mass density, those are wires also you can check where guitar or sitar, different instrument. And statement to resist support, this is a tension which is applied. It resonates with this wire, produces sound of a particular frequency. The next higher frequency is 490. Find the length of the wire. This requires a bit of understanding of standing wave. Can anyone think of way of solving this question? So one of the two frequencies are given. We don't know which harmonic are those. We don't know which harmonic are those. So two frequencies are given. One and the next higher. So can you think of way of solving? So what are the frequencies in which a string oscillate? So possible frequencies are what? Possible frequencies are n into f naught, fundamental frequency, where n can take a value of 1, 2, 3, 4, 5 and all. So when they say that next higher means, let's say the first one. This one is nth harmonic. If this is harmonic, next higher frequency, this has to be n plus 1th harmonic. So 420 hertz, let it be nth harmonic. So if it is nth harmonic, how do we write? 420 is equal to n into f naught. And second, if this is nth harmonic, 490 hertz. If this is the nth harmonic, this will be n plus 1th harmonic. Because the next, so which gives you 490 is equal to n plus 1 f naught. From here, what we take a difference between the two. What we find out, f naught is 70 hertz. So we otherwise also we could have figured out what is the difference between two successive harmonics. Difference between two successive harmonics is nothing but fundamental frequency. So for this wire, fundamental frequency is 70 hertz. Indirectly, what is the information given? Fundamental frequency is 70 Hertz, and fundamental frequency is equal to V by 2L. So once we find fundamental frequency, we can find what is the length of the wire. Now, where is the velocity? Velocity is given here. What is the velocity of speed at which the wave travels in the string? Root of T by mu. Is the T given here? Yes, T is given here. Estimate to support tension is 450. And 5 into 10 to the power minus 3. So we can find L. So F naught is 70 is equal to 300 divided by 2 into L. Of course, this will be in meters. What we have done today, what is standing wave? Again, just to actually this topic is most of the question fairly simple. Oh, standing wave, what gives rise to standing wave? Waves of equal amplitude and equal frequency traveling in opposite direction gives rise to standing wave. Traveling in opposite direction. Okay, and how do we obtain this expression for traveling wave? How do we find expression for standing wave? We just simply take the principle of superposition, and we get an equation which is of this nature. And after we apply this fixed end condition, we get something like this. Okay. And from here, what we understand, this is standing wave form. And then we define, we're applying the fixed end condition. Then we have what we have done, we have understood, we have defined something called nodes. When standing wave points, some points of, in case of standing wave, it is equivalent to all the particles on the string oscillating with same angular frequency omega, but varying amplitude. Amplitudes vary. And there are some points where amplitude is 0. Those points are called nodes, and distance between two successive nodes is equal to lambda by 2. And in between two nodes, there's a midpoint between two nodes will have maximum amplitude of oscillation, which is called antinode. So different distance between antinode and node is equal to lambda by 4. So when a string oscillates, L is equal to n times lambda by 2, and each lambda by 2 is a kind of loop. So what you understand here, when a string is oscillating in nth harmonic, n loops will form. When it is oscillating in fourth harmonic, 4 loops will form. Okay, and then we also write a fundamental frequency. Fundamental frequency is V by 2L, and any other nth harmonic is n times V by 2L. That's what I think key points are, and the rest all is simple application of the same, and we can solve.
Sure.
Yes.
Sir, I didn't really understand the diagrammatic representation. Like, why do we draw that double loop, sir?
Why do we call?
No, why do we draw that double loop when we are indicating the?
Why do we draw a double loop? Okay, let us come to this equation. Okay. See, suppose we have an equation. Let's take this equation itself. What is this equation? See, suppose I substitute t is equal to 0. What would this equation indicate if I substitute t is equal to 0? See, in terms of what would this equation at a particular time indicate?
The position of each particle at
each particle
t is equal to 0.
And if we connect all the particles, it gives the shape of the string at t is equal to 0.
Yes, sir.
So if I plot what will be the shape here, if t is equal to 0, if I substitute, this term becomes equal to, if I put this t is equal to 0, this term becomes equal to 1. So the shape at what is y at t is equal to 0? Can you draw it? Right? Okay, sorry. Where this question go? What is y? Y will be equal to 4 sine
pi x by 15.
What does it mean? The shape of the string will be similar to a sine curve. Does it not mean the same thing?
Yes,
and not only at any time, any point of time, the shape of the string will be like a sine curve. And
Yes,
if the length of the string is a line sine curve, and here you plot. So when it is sine curve, so again you start from 0, again it will touch 0 at some point of time. And if the length, depending on the length, it will keep on, this is the shape of curve.
yes, sir.
What will happen at time t is equal to t by 4? There's some time when this term becomes equal to 0. When this becomes 0, what does it mean? What will
All the
shape
particles are at the mean position.
mean position? So it is just using the equation that a particle will come to mean position. So what has
Yes, sir.
happened in time t by 4? What has happened? This particle has moved from here to here. This particle has moved from here to here. This particle has moved from here to here. And this particle has moved up like this. And this is how it has moved. That is what has happened
Yes,
in
sir.
time t by 4. And
Yes,
how
sir.
do we get number of loops? Number of loops comes from this equation. I find what is the distance between 2 points which are always at rest. You can easily find which are the distance
Yes,
between
sir.
2 points which are always at rest.
Yes, sir. Sir, my doubt was like at the diagram you drew at the bottom of the screen here, sir.
Yes.
You drew a sin x and a minus sin x curve, right?
No, basically I'm saying if I keep observing different shapes of the string, it will appear like this. See, a string, if I take multiple snapshots and superpose all together, this is how the shape of string will look like. Not one snapshot.
Yes, sir. Okay.
If we take multiple snapshots at different times and superimpose all on each other, it will show something like this.
Yes, sir.
Okay.
Sir, I have a doubt in the derivation.
Yes.
Like why did we take delta as 0? Why not 2 pi, sir? Like we got sine delta by 2 should be 0, right?
Yes, we can take 2 pi also. But 2 pi also, if you take, does it alter anything?
Yeah, it does not.
It does not alter. See, I think what you have to understand here, when we write this equation, this is something, see, one thing what you need to understand, just think of it. The equation gets altered based on choice of origin and choice of time when we start our measurement. You understand the choice of time when if we choose some other time, the equation becomes changes, and when we choose a different point as origin, equation changes. And those things, and see, it is that important to understand. See, suppose we have a wave which is in a fundamental mode. The fundamental mode is vibrating like this, and my equation is something like this. What is y? Y is equal to 2a sine of lambda is equal to L by 2. So basically k is equal to 2 pi by lambda. Lambda is equal to pi by. Okay. Now suppose this person has made observation starting at some instance of time. Other person here taken x is equal to 0. What happens if I take x equal to 0 at L by 2?
Then the equation will change.
Equation will change. But both the cases, when the equation changes, somebody say, oh, then the equation becomes different. So basically, when we choose a particular origin and time, which makes our derivation simpler.
Yes, sir.
Okay, so you have to understand this point. It keeps sine, cos, and phase constant. All keep changing depending on choice of what we take as origin and when do we start. The second person B, this is one person A, what he has taken a particular time. He has taken time t is going to start at certain time and he has taken this as 0. Other person starts his measurement time t is going to not here. He start at t by 4. He will get a different equation. This term also will change.
Yes,
and wave equation also will change. Are you getting my point now?
Yes, I understood.
The phase constant also will change.
Yes.
See, when we write other important, see, this is something, see, wave equation, actually, if you're solving, okay. Now coming to your reflection question. Reflection question also, it is basically based on if I choose the reflection, okay. When we write those equation, there's a particular choice of x even there also. See,
so
here,
like we're measuring x from different
what we are
positions.
assuming here, what we are assuming in this case, we are assuming here, see, there's a wave traveling here, which is something going in one direction. There's another wave traveling in the opposite direction. Okay, and we have chosen something as x is equal to 0, and we have chosen certain time. I have chosen a time such that here this constant comes to be 0. When I take this to be 0, it is not necessarily, I'm not necessarily taking this a reflected wave. I'm taking this another wave which is coming. We are just taking superposition of two waves traveling in the opposite direction. All we are
Yes,
saying
sir.
this opposite wave, where from it has come from reflection.
Yes, sir. Because from the source, a continuous wave is being created, right?
So this is something, see, and I'll come to that point later. See, if you look at your book, and so many books, they create certain questions which are not correct. See, they say, in fact, book also will come to that question, and they say if you string, some question are there like this. If you pluck the string, but basically if you take a guitar string, you pull the string at the midpoint and leave it. It creates some vibration, and what some of the books say, if you pluck it at L/4 distance, but basically you pluck the string like this and leave it, it will vibrate in second harmonic, which is not correct. This is not how it happens. So I hope you understood this point here. We are taking two waves which are traveling in the opposite direction, and the wave equation, when you take it, depends on choice of x and t. So we have chosen a time here. We have see other thing I think you didn't ask. Yeah, why you have not taken omega t minus kx? You have taken kx minus omega t. Let's go. See, all those things depends on choice. Whether we can this term here, when we shift value of x here, it may be pi term, it may change, it may become negative. Reason we take this form yields to a form which people find easier to understand. It comes as sine function.
Yes.
If you take something else, then again the origin will not coincide with the node. Then becomes a little complicated to understand. What happens if the same equation origin doesn't coincide with the node? It will have become a little more complicated equation, though it will represent the same thing.
Yes, sir.
Okay. Okay, then I'll stop here.
Sir, I have a doubt, sir.
Yes.
Sir, like when we say L equals n lambda by 2, we mean it that the node should be on the opposite ends, right? Like